Hello everyone, in today's video we will be doing some exercises based on what we talked about yesterday. This first exercise is about making the distance from the points to the lines. As you can see, we have 6 points and 6 lines, and we want to make the distance from each point to its line. So, a reminder of how we do that. We take the ruler. Here we have a ruler. We rotate it to make it perpendicular to the line. That looks perpendicular, but let's zoom in a little bit to make sure that it is. Yep, as you can see right here, this line is the black line on the ruler is aligned with the blue line. So it is in fact perpendicular right now. So I'm going to place it on the point, and then I'm going to draw with my pencil. I'm going to make a line that is perpendicular to the blue line. And that black line that I just made, that is the distance from the point to the line. Next up. Okay, so here you might notice that if I go to measure the distance, if I want to make a line that is perpendicular to this line, then there's nothing here basically. So a reminder again of what we talked about yesterday. What we do when this happens is we project this line to think, okay, well, where would it go if it did continue? But this line needs to be aligned with our original line. We can't just make it anywhere we want. So I need to place my ruler correctly. So I placed my ruler like this, and if you remember from yesterday, we said that shouldn't be full lines because this isn't actually part of the line. It's what would be part of the line if it continued this way. So that's why the lines are cut. Then I will rotate my ruler again to make it perpendicular to the blue line. So right here, right? Let's see. Yep, there we go. This black line is now aligned with the blue line. I will bring it to the point right here, and then I will make a line from the point to the imaginary part of the line. So there we go. That black line right there is the distance from this blue point to the line. Next up, again, you see that if I want to make a perpendicular line to this one, we actually can't. So we need to project this line. That's not totally straight. There we go. Okay, so I'm now going to create a new line that is projected from the old one. And I will make it be cut a little bit. I will rotate my ruler to make it perpendicular to the blue line. And then I will bring it in to the blue dot. Wait, is it perpendicular? It looked perpendicular, but let's zoom in a little bit. It could be a little better. There we go. And then I will bring it to the point, and I will make a line from the point to the imaginary part of the line, and that is the distance from the point to the line. Let's go, next one. Down here. Okay, this one's, well, this one's a little easier because you can see that if I want to make a perpendicular line from here to here, I just need to bring it in like this. I don't need to project anything now. So I will simply rotate my ruler, make it perpendicular to the blue line, and then bring it up to the point so that it touches the point. And then I will make a line from the point perpendicular to the line. And there we go. That's the distance between the blue point and the line. Next up, here, if we want to make a line that is perpendicular from here to this one, then we're going to have to project it. And the same goes for this one as well. So rotate and align. Not exact. Not exact. There we go. That looks better. There we go. And then I will project my line along the ruler. I will again erase part of it to show that it is imaginary. It is not actually there. I will again rotate to make my ruler perpendicular to the blue line, and I will make it so that the ruler touches the blue point. There. We want to go for the center of the blue point. We don't want to go for the edge. And then I will make a point. I will make a line from the point to the imaginary part of the line. And that is distance from the point to the line. Next up, last one. We need to project this line. And thinking of which way we should project, I didn't mention this, but maybe I should have. Thinking of which way to project the line, so am I going to project it this way or am I going to project it this way? You can see in all the lines that we have projected that we were projecting from the point that from the end of the line that was closest to the point. So this one was closest to the point and this one was closest to this point. So here I'm going to project from here this way. If I projected from here this way, that wouldn't really help me. Let's rotate a little bit. Zoom in a little. Detail is very important, especially in geometry. We project the line, continue. It doesn't matter how far I want to project it. Could be here, could be here, as long as we get past the point. Yeah, maybe I shouldn't have made it this long. Didn't need to be. Okay, so next up, we rotate our ruler again, make it perpendicular to the blue line. And then bring it in to touch the blue point. And then we bring in a line from the blue point to the imaginary line, and that is the distance from the point to the line. Okay, great. So that's how we do all of these. As you saw, this is how I make the distances from line to point. Okay, now let's delete. No, let's not delete. Let's just hide all of these. There we go. And move on to our next exercise. Here we want to first define all of these triangles based on their sides, and then we want to draw all of their heights. Let's do the first one. First one says that we need to define them based on their sides. These two first triangles, as you see, since I haven't put any lines in, that means that no two sides are equal, making them what we called yesterday scalene triangles. So this is a scalene triangle, and this is a scalene triangle. In this triangle, you might want to call it a right triangle because, as you can see here, it has a right angle, but that would be incorrect because saying that it's a right triangle, well, yeah, it is a right triangle, but the problem asks us to define the triangles based on their sides. Saying that it's a right angle, so it's a right triangle, so it's something about its angles, not its sides. From its sides, what we can see is it has two equal sides. That makes it called these triangles that have two equal sides. Yesterday we called them isosceles triangle. And when they have all three of their sides being equal, we call them equilateral. So this is an equilateral triangle. Great. The next one says draw all of their heights. Now what does it mean when it says all of their heights? It means that it doesn't just want the height from the point that is on top, it wants the heights from all the points of the triangle. So basically what it's saying is find the distance between each point of the triangle to the side that is opposite of it. That's basically what it's saying. So for example, it's exactly what we were doing in the previous exercise, just with triangles. So for example, let's say we have this point right here, right? I need to find its distance from this side. I need to find basically like what were we doing before? We were finding the distance between points and lines. Well, that's what we need to do now as well. We need to find the distance between this point and this line. But also, after we do that, we need to find the distance between this point, and this line. Because this is the side that's facing this angle. This is the side that is not touching this point. And then once we're done with that, we are going to need to find the distance between this point and this side. We need to do all three of those. Okay, so let's get started. Let's bring out our ruler again. That's where we left it. Oh. So I'll start with the top one since it seems like the easiest. And as you can see, I don't need to project this side at all. We can bring the perpendicular line. So let's see, have I rotated it well enough? I think it's currently perpendicular to this side, and it is. Again, I'm trying to find the distance between this top blue point and this side. We want to find the distance between the point and the side that is not touching it. So for this point, this is the side that is not touching it. So we are going to make a line that is perpendicular from this point to here. And that is the first height of this triangle. That is one of the heights of this triangle. Next, I'm going to make a perpendicular line from this point to this side. So I'm going to take my ruler, rotate it to make it perpendicular. You might not immediately know if you need to project the line or not. So here, for example, you might not be sure if you can make a perpendicular line without projecting it. The way you can see that is make your ruler perpendicular to the side that you care about. So here, for example, I have already made the ruler perpendicular to this side, and try to bring it in to touch the point without leaving the side. So here you can see that my ruler is still inside this line. It hasn't left it yet. So indeed, I do not need to project it. I can just make this line. It was pretty close though, as you saw. Now, next up, for the height that is going to go from here to this side, again, I'm not quite sure if I need to project it or not. So I'm first going to make my ruler perpendicular to this side. So is it perpendicular? Not 100% sure. So it looks to be. Yes, the 20 line is aligned with the side of the triangle. So yeah, again, I do not need to leave the line. I don't need to project it. I can just make a line here. And that is the height of the triangle. And there we go. We made 3 perpendicular lines from each point to the side that was facing them, to the side that was not touching them. Next up. Okay, in this next one here, I'm going to start with the easy one, and then we'll move in to the rest. As you might already be able to guess, there's only one easy one. That would be this point. I'm actually going to mix the dots again. Maybe that helps someone. So this is 1 point, this is 2 points, this is 3 points. This point needs to be, we need to find the distance from this point to this side, because that's the one that's not touching it. Then we need to find the distance from this point to this side, because that's the one not touching it. And then the distance from this point to this side, because that's the one not touching it. We'll start with this one because it's the simplest one, because it doesn't require that the line be projected. So first of all, let's make the ruler perpendicular to the side, and there we go, it already is. Perfect. And then we just draw a line from the point to the side, and there it is. The distance between these two, again, is called one of the heights of the triangle. Okay, this is one of the heights of the triangle. All right, and this is where things get a little tricky, because as you can see here, I can't draw a perpendicular line if I make my ruler perpendicular to this line. I want to make a line that starts from this point and heads towards this side, and is perpendicular to it. If I move my ruler this way, you see that in order to reach that blue point right there, I need to leave this line. I'm no longer in the line. So I'm going to need to project the line I'm going to need to project the line this way. And we don't need to make it too long, just as long as it passes this point. Again, this isn't actually part of the line. It's just an imaginary. It's in our heads. Then we rotate the ruler again, make it perpendicular to the side. We check if we did it correctly. One of the lines needs to be aligned with this side, and apparently it is. And then we bring it to touch the blue point, and we draw this line from point to the imaginary part. And that line right there, that is one of the heights of the triangle. This was one, this is another one. Then we need to find the height from this point. And again, from this point, we need to bring a perpendicular line to this side, because this is the side that isn't touching it. So again, we're going to need to project. You may have already noticed that I cannot bring a perpendicular line from this point to this side because it's too far. Okay, there we go, perfectly aligned. This would be a lot more accurate if we actually had pencil and paper. This will have to do. And it would also be much easier to show you how to do this, but again, we'll have to make do. I rotate my ruler to make it perpendicular to the side. There we go, it's aligned. And then I move it over to the blue point. Then I draw this line right here. From the point to the imaginary part, to the projected line. And there we go, those are all the heights of this triangle. 1, 2, 3. Next we have this one. Okay, this is a little curious, because as we said before, this line, this angle, sorry, is a right angle. So what will happen when I try to find the heights from here and from here? Well, let's see. I'm going to take my ruler. The height from here is going to need to go to this side because this is the side that isn't touching the point. So let's make my ruler perpendicular to that side. Let's see if we got it correct. Yep, there we go. It's perpendicular now. And then when I place it on the blue point, what you see is that what we get is this side that's already made. We don't get anything new. It's already this side. And that's why we say that this side is already the height of the triangle. And then the same happens for the other line, where if the height from this point is going to need to reach this line, because that's the side that's not touching it. So I make my ruler perpendicular to this side of the triangle, and then I bring it down to the blue point, and what you see again is that I get exactly the side of the triangle. This is a property of right triangles. In right triangles, the two sides that create the right angle are also heights of the triangle. And it doesn't need to be an isosceles right triangle. So the sides don't have to be the same in order for this to work. For any right triangle, the two sides that create the right angle, so this one and this one, are heights of the triangle. But for this one, we are going to need to make a line because we need to go from here to here, and we need to make a perpendicular line from here to here. There we go, perfectly aligned. And now I bring my ruler in here, and I make a line. And so that's the height of the triangle from this point down here. And again, the other two heights. Sorry. The other two heights from here, it's this side, and from this point, it's this side. So let's state that one more time. For any right triangle, the two sides that make the right angle are also heights of the triangle. Let's move on to the last one, our equilateral triangle. So here we want to make the heights from here here, and here. We will take our ruler. I'm going to start from this one, although it doesn't really matter. I don't need to project any of the lines here. I want to make it perpendicular to the bottom side, since that's the one that's not touching this point. There we go. And then I'm going to draw the line from this top point right here. And that's the first height. Now I will turn my ruler to make it perpendicular to this side. And you see that it's already in position for me to make the next height. And now I will do the same. I will turn it again, I will rotate it again so that it is perpendicular to this side. There we go. And now I will bring it up right there. Oh, I could have gone a little higher because theoretically this is a little extra, but okay. If we were being really precise about this, like 100% precise about this, with pencil and paper, of course, then all the heights of an equilateral triangle need to intersect at the same point. That's a property of equilateral triangles, and you can see it here that they do in fact all intersect. All three of them intersect at the same point. That's a little extra. It's nothing in particular. Well, all we wanted was to find the distance from each point to the side that faces it, to the side that is not touching it, and that's just what we did. And that's how I make the heights of these triangles. And that's what you're going to have to do in tomorrow's, well, in the exercises of the next few days. So if you need to remember what we did here, just come back and watch the video, or a specific part that you need to rewatch, anything you need. And if you have any questions, remember to leave them in the comments of the video or ask Mr. Costas on the live meetings. So I will see you guys again on Friday when we do the correction of your worksheets.